So far we have learnt about plane mirror. Now we will try to introduce ourselves with curved mirror, the surface of which is curved. The surface of which is curved. One very common example of curved mirror is a spoon we use every day. This spoon. This reflects because this is very bright, very smooth, so this can reflect. See, this board marker is reflected here. See, watch, it is reflected. But the feature is, see, the tip of the board marker inside the reflector is downward. But if we rotate it, the opposite side is showing the upright figure. So curved mirror may have these types of features. Curved mirror generally are spherical mirrors. Mirror which is a part of a sphere. A ball. If you cut a slice of it, it will look like this. One side inflated, the other side depressed. Light may reflect from either of these two sides. If this side is coated, inflated side is coated, light will reflect from the depressed side. In that case, the mirror is called concave mirror. If the depressed side is coated and light reflects from the inflated side, the mirror is called the convex mirror. Now we will learn some terms related to spherical mirrors. To do that, we have to draw the spherical mirrors. But spherical mirror is a three-dimensional object. It cannot be drawn on a two-dimensional plane. So what we will do? We will draw the edge of the mirror like this. The center of this curved line, geometrical center, is called the pole. If this surface is coated, this point is called pole, the geometrical center. Or if the mirror is this geometrical center is called the pole. Since this is a part of a sphere, the sphere must have a center. This center is called the center of curvature. Similarly here, suppose center of curvature. The line passing through pole and the center of curvature is called the principal axis. This line is called principal axis. This line is called principal axis. The distance from the center to the curved surface is called radius of curvature. Suppose here, this is called radius of curvature and is denoted by small r. Here also we can draw. This distance is radius of curvature. So this distance also the radius of curvature, PC. PC is also radius of curvature. Radius of curvature. It is observed the rays, light rays parallel to the principal axis will meet at a point on the principal axis or appear to meet at a point on the principal axis. They meet on the principal axis at a point in case of a concave mirror, and they appear to meet or appear to emerge out from a point on the principal axis in case of a convex mirror. Let me draw. I have taken two parallel rays and parallel to the principal axis. They will meet at a point on the principal axis. This point is called principal focus, and this point in case of a concave mirror is in front of the mirror, whereas it is behind the mirror. Light will come from this side in case of a convex mirror. Let me complete the diagram. I have taken these two parallel rays parallel to the principal axis. They are reflecting. If you produce them, if you extend them at their back, they will meet at a point on the principal axis. This is called principal focus of a convex mirror. So principal focus of a convex mirror is behind the mirror. Actually the rays are looking like they are emerging out from this point. The distance from pole to the principal focus is called focal length. Pole to the principal focus is called focal length. PF, this distance is called focal length, and it is observed that F is exactly the midpoint of this PC distance, exactly the midpoint of PC distance. So PF can be written as half PC. Already we have learned PC is the radius of curvature, half r, and PF is the focal length, F. F is equal to half r. Or we can write r is equal to 2f. Radius of curvature is twice the focal length. This is the relationship between radius of curvature and focal length. The area of the mirror from which reflection takes place, either concave mirror or the convex mirror, this area is called the aperture of the mirror. Actually, aperture is of two types. The distance between these two ends, linear distance, is called linear aperture. Let me draw. The distance between these two extremes, the length of this straight line, is called linear aperture, either in case of a concave mirror or in case of a convex mirror. This is called linear aperture. And the angle subtended at the center of curvature, if there is the center of curvature, angle subtended by these two extremes at the center of curvature is called angular aperture. And here in this case, suppose this is the center of curvature, so the angle subtended by these two extremes at the center of curvature, this angle is called the angular aperture.